welcome to Math 106, Module 8.8. This is our very last lecture video for this Math 106 course. So at the very end, we want to wrap it up with translating English phrases and algebraic expressions. So basically what we're going to do in this lecture video is to learn how to translate these English words, or what I call them operation words, into algebraic expression. All right, so here are the key words to look for when we're translating phrases. I'm going to highlight some of the important ones as well. A lot of these words you probably already learned about them throughout this course. So as we get deeper into algebra, some of these words become more and more important. All right, the word sum. When you say the word sum, you will simply write an addition sign. Okay, the word sum actually has two meanings. It means addition sign. It also means the answer that we get after we add. All right, more than, anything sounds like more than, okay, means addition sign, like older than, okay, longer than. Anything sounds like more than means addition sign in algebra. Now, when it comes to translating words for subtraction, okay, it's a little bit tricky, a couple of them. All right, the word subtract, which is not here, is actually quite common. The word subtracted from, excuse me, no, let's do the word difference first. The word difference is a lot like the word sum. Okay, the word difference means subtraction sign. The word difference also means the answer we get after we subtract. Now, the trickier ones are the wording subtracted from. Okay, not the word subtract is different than subtracted from. I'm going to put the word subtract down here. Subtract is the regular minus sign, but the subtracted from, the word less than, okay, is actually a little bit tricky. When you see the word subtracted from or the word less than, you will translate those backwards. Okay, so what do I mean by backwards? For example, okay, the answer here is not what's important. It's the way how we go about translating these sentences or phrase. So when you see 7, you write 7. When you see the word subtract, you write subtraction sign. So when you see 5, you write 5. So the wording 7 subtract 5 is exactly what you think it is. 7 minus 5 or 7 subtract 5. So now when you see 7, you write 7. But when you see the word subtracted from, you remember Mr. Chen said something about you got to translate that backwards. Backwards means normally when we write subtraction sign, we write behind what we just wrote. Backwards means now we will write in front of it. 7 is subtracted from somebody that is in front. Subtracted from who? Subtracted from somebody up front of 5. So 7 subtracted from 5 actually means 5 minus 7. Same thing with the word less than. When you see 7, you write 7. When you see less than, you will write subtraction sign backwards instead of writing behind what you normally wrote. Backwards means now we will actually go back to the left side. So I will write a subtraction sign in front of what I just wrote. 7 is less than who? Okay, 7 is short from who? It's short from 5. So when you translate less than, okay, you actually write the subtraction sign in front of what you just wrote. All right, the word difference, okay, means subtraction sign. So whenever we write down a subtraction sign or a plus sign first, there got to be somebody go in front of it and somebody go behind it. And normally the problem will tell you right away is a subtraction between somebody, and you tell me it's a subtraction between 7. So when I see 7 first, I write 7 up front. When I see 5 next, I write 5 behind the subtraction sign. Okay, so the difference between 7 and 5 actually translates to be 7 minus 5. So why do I have to put 7 in the front? Because 7 comes first in the sentence. If the problem want me to put 5 up front, 7 on the back, it would then say the difference between what? 5 and 7. Okay, so that's for subtraction. Subtraction with the wording less than and subtracted from, just remember we got to translate those backwards. All right. When it comes to translating multiplication, the word product is very often used. The word product is like the word difference in the sum. It has two meanings. It means multiplication sign. It means, it actually also means the answer we get after we multiply. Believe it or not, we use the word times a lot. Okay? Whenever we see the word twice or double, those mean 2 times something. Put the 2 in the front. Okay? 2 times something. One word is not here, but we actually normally run into. We actually did run into it back in Module 4. The word of. I'm going to put in a quotation mark. Because sometimes the word of means multiplication. Sometimes the word of means of. So when does the word of means multiplication sign? Well, when we are dealing with percent type of problem. All right. For example, maybe like what's 5% of $50? So that will be translated to be 5% is 0.05. Of means multiply the $50. Okay. So now the word of in percent means multiply. The word of also means multiplication when we are dealing with fraction kind of wording, like a third of, half of. So when you see the wording a third of, it means 1/3 times something. Okay, so wherever we use fraction wordings, okay, we always use the word of. We don't translate division very often. Okay, once in a very blue moon, we will do that. So normally the word divide or the word quotient, okay, will be translated for division. Okay. Now we rarely translate for exponents. Now one thing we normally run into, perhaps not in this class as much as in Math 108, equal sign. Translating for the equal sign is extremely tricky because it does go by the context of the word problem. But sometimes equal sign. But sometimes the word is means equal sign. Okay? Sometimes the word is just is. So we are looking for phrases like is the same as. Okay? Any type of phrase like that can be translated as equal sign. Okay, so let's give this a try. Okay, let's give this a try. I got several examples. So the following examples serve no purpose other than practicing on picking up on these translation words. Okay, you got to kind of memorize what some of these words are, so you know when you see it, you know you're supposed to translate those words. All right. So translate the following phrase into algebraic expression. Do not simplify. We're just going to translate. So when I see 9, I write 9. When I see the word less than, okay, remember just a minute ago, less than means subtraction sign, okay? We got to translate it backwards. That means put it in front of what I just wrote. 9 is less than who? 9 is short from who? It's short from the sum. So when you see the word sum, you're supposed to write an addition sign. But where do you write it? Well, since we are translating backwards towards the left, we will put the plus sign in front of that subtraction sign. But when I write a plus sign, then there got to be somebody go in front of it, somebody go behind it. 9 is less than the sum of who? Of x, and the other one got to be y. So this problem is basically saying x plus y minus 9. Okay? But that's not exactly what it says, is it? Does the problem ever say y subtract 9? Or 9 is less than y? No, the problem actually said 9 is less than the entire sum of x and y. That's the reason why the x plus y got to be in the parenthesis first. Okay? That means we will actually add the x and y first before we will subtract the 9. Okay, that's what this backside is saying. 9 is less than the entire sum of x and y. Okay, so this problem, you got to have a parenthesis for the x plus y. So it's very tricky from time to time. All right, try another one. When I see y, I write y. When I see multiply, I write multiply. Multiply by who? The product. Okay, product means multiplication again. So when I see the word product, the word sum, the word difference, I know there got to be somebody go in front of it, somebody go behind it. Y is going to be multiplied by the product, the multiplication of who? 9 and x. Okay, so it seems like the problem is saying not y times. Seems like the problem is saying y times 9 times x. So if we say it like that, okay, if we say it like that, that seems like y will times 9 first. But the problem never says y will times 9. It says y will be multiplied by who? By the entire product of 9 and x. So that's why 9 times x got to be in the parentheses. All right, let's try this one, okay? The first word I got to translate, so we got to pick up on these words. The first word we translate, sum. Sum means addition sign. So when I write a plus sign, there got to be somebody go in front of it, somebody go behind it. It's a sum of who? Of 2. I write 2. X and x. And here it says and y. So that means it's a sum of 3 different things or 3 different terms. So that means it's a sum. So I need to add another plus sign here because I'm adding 3 things. Hang on a second. I'm freezing up again. All right, it's a sum of 2x and y, okay? It's a sum of 2x and y. So this problem is 2 plus x plus y together, okay? All right, so let's translate again. Okay, do not simplify. Use a variable names, x and y, to describe the unknown. All right, let's try this again. Okay, the word sum, I write plus sign. So when I write a plus sign first, there got to be somebody go in front of it, somebody go behind it. The sum of who? Of 2 numbers. Those 2 numbers got to be x and y. Increase by means plus 7. All right, so if you think about it though, does the problem say x plus y plus 7? That means does the problem kind of saying y plus 7? No, the problem actually says it's a sum of these 2 numbers, x and y first, then increase by 7. That's why, again, x plus y got to be in the parentheses. All right, let's do one with division. 5 divided by. So when we translate for division, we normally write them as a fraction because fraction bar means division. It's divided by who? Divided by the next word I translate. All right, it's 5 divided by, come on, there you go, 5 divided by, all right, so after the fraction bar, that means what? That means everything else behind divided by got to be in the bottom. Sum, I write plus sign. 5 divided by the sum of 4 and a number. Okay, so that will be, so 4 and a number, 4 go first. 4 in a number, so I can just write x. 4 in x. All right. Let's try another one. It's kind of weird because you would think divided by means. You would think the wording divided by means almost seems like 4 plus x would divided by 5. Not really, because the 5 is a dividend. So the dividend technically go in the inside. This 5 is going to get divided by who? By the 4 plus x. So the divisor goes on the outside. So that's why the translation makes sense. Okay? Is the 4 plus x is trying to go into the 5. Okay? That's the reason why 5 divided by. After the word divided by, everything else got to be in the denominator. All right. Again, the sum of two numbers increased by 7. That's the same problem as the one before. I didn't mean to duplicate that. All right. Let's try a different type of problem, okay? So those few examples I have, I'm showing y'all, is simply kind of show you how to pick up on these translation word, okay? Probably the one that I did not go over is the word more than, okay? So if you got a take Math 108 and in Module 9 when we begin to do more word problems, you will see the word more than very, very often. All right, now 1, 2, 3, 4. Here I got 4 examples. So these 4 problems is not like the it's not quite like the translation problem, the one we just practiced. These first 2 is actually a part of a big word problem. Okay, it's just here we just want to kind of translate a small piece of it from a big word problem. Okay, so there's a way to actually read the sentence. So this is how it works. The number of seconds. Okay, the number of seconds. What that means is my answer needs to be in second. In m minutes and 40 seconds. So, how many minutes do I have? Well, I have m minutes, but everything needs to be in seconds. So, 1 minute is 60 seconds. So, m stands for minutes. So, to convert minutes into seconds, I got to times by 60. All right, so 60 times so many minutes I'm going to have, okay? And I got additional 40 seconds. So I got to plus another 40 seconds. So these two terms together representing the number of seconds in so many minutes. So if you actually think about what it says, it quite did not make sense, okay? It quite did not make any sense. Because a lot of times algebra word problem doesn't make any sense. So our job is simply kind of translate what it says. So if I will pretend this m representing, this n represent 10 minutes. So let's say I got 10 minutes and 40 seconds, and I need to write my number in seconds. Well, what would be the first thing you do with the 10 minutes? Let's pretend m is 10. The first thing you will do is take that 10 minutes and then convert into second, which you will multiply by 60. So once you turn the 10 minutes into seconds, then you're going to add another 40 seconds. So basically, I'm just replacing my 10 minutes into some sort of variable. So that means if I have so many minutes and 40 seconds, and I want my answer to representing seconds, then the first thing I do is turn my m minutes into seconds, which is times by 60. Then we will plus the 40. Okay, so that's my answer. All right, let's try a different type of problem here. Let me show you how to read this, okay? These problems is a little bit strange to translate. The cost of renting a car for 1 day and driving so many miles. That's called the m miles. So my answer need to representing the cost of renting this car and driving. So if the rate, so right here is what I need to figure out. The rate is $24 per day plus 25 cents per mile. So what that means is to rent the car just for 1 day, okay, I got to spend $24. Well, I am renting a car just for 1 day. So in order for me to pick up the keys for that car, I got to pay the $24 no matter what. Doesn't matter if I drive 1 mile or 100 miles. In order to pick up that key, I got to already pay $24. I'm freezing up again. Give me a second. I hate this part. So $24. So everything is going to be representing money, cost, plus, all right, plus, so $25 no matter what, plus 25 cents per mile. So if I'm driving 10 miles, that will be 25 cents times 10 miles, right? If I'm driving 100 miles, that will be 25 cents times 100 miles. So if I'm driving n miles, that will be 25 cents times n miles. But be very careful here. The 24 representing dollar. Right now, when I put 25 here in front of the n, that 25 stands for cents. So I need to convert my cents into dollar amount. So 25 cents, as we know, is $0.25. So my answer got to be $24 plus 25 cents. I write 0.25 times m number of miles that I need to drive. So that's how we'll translate, okay, for this piece of information. Now, the next two problems will actually contain those translation words I mentioned. Okay, I call these type of problem the comparison problem, because what we're doing here is trying to comparing items. Okay. So I'm call them comparison problems. All right. Something is compared with something else. So let's check it out how these problems work. So this problem whatever my answer is gonna turn out to be, need to represent the cost of purchasing a fish rod in the reel. All right. So let's translate for my item, comparing something and one item to another item. It says if the rod costs 7 more than. So whenever we do translation problem, you got to pick up on the translation word, because wherever the translation word is located, okay, that phrase or that sentence will contain, okay, it will contain the items that are being compared. In other words, who is $7 more than twice of who? Who is $7 more than who? Well, it turns out it's the rod. The rod is $7 more than twice of who? Of the reel. So that means my two items are rod and reel. So whenever we're comparing only two items, okay, from the translating sentence, you let the second item to always to be X. Why? Because it's easier to read from left to right and translate from left to right. So you let the second item to be X. So then we go by translate for the rod. Rod cost. Cost is like the word equal sign. So that means here I got rod equal. When I see 7, I write 7. When I see more than, I write plus. When I see the word twice, I write 2 times. 7 more than 2 times who? 2 times the real. And I already call real to be X. So that would be 2 times X. All right. So my translation tells me the cost for the rod is going to be 7 plus 2x. the cost for the real is going to be X. So that's just translating for the two items. How do I write my whole answer out? Well, the whole answer need to representing the cost of purchasing a fishing rod and the reel. All right, so that means what I highlight in yellow means my answer need to be rods plus the reel. The cost of rod plus the cost of reel. All right, so this plus sign here means the cost of buying both the things. So what did I just translate for the rod? 7 plus 2x. Now plus the cost of reel, which is x. So that's my answer. 7 plus 2x is a rod, plus the reel is x. Okay. So again, this is one piece of a big word problem that we are going to see in Math 108. Okay. All right. Let's try another one, just like it. The perimeter of a rectangle. So my answer need to represent the perimeter of a rectangle. It says if the width is W centimeter already, and the length is 10 centimeter more than, so that's my translation word. Who is more than who? Who is more than who? The length is more than the width, okay? So my two items that I'm trying to compare is length and the width. All right, so normally when we only comparing two items, the item listed at the end of the translating sentence is always X. But I'm not going to use X here because the problem already told me use W for the width. Okay, so let's go back translating for the word length. Length is, remember earlier I said the word is means equal sign. When I see 10, I write 10. When I see more than, I write plus sign. Length is 10 more than who? Twice. When I see twice, I write 2 times. 2 times who? 2 times the width, which I already called it to be W. All right, so the length will be translated into 10 plus 2W. The width, the problem already told me just call it W or X. Okay, this time they want me to do W, not X. So when I write my answer out, my answer need to represent the perimeter of a rectangle. So if you think back on module 6, perimeter of a rectangle is 2L plus 2W. Since I don't know what my perimeter is, this problem never told me what the perimeter is. So that means my expression just need to be 2L plus 2W. It just need to be the other side of my perimeter. Okay, I don't know what P is, so I'm not trying to set them up as an equation. I'm just setting them up as an expression. So you can kind of tell this is only half of an equation. This phrase we're translating is only half, okay, of an equation that we will learn how to translate to work out in module 9. All right, so let's write in what we translated. Don't simplify, okay? So 2 times L, the 2 come with a formula, so that will be 2 times. All right, I just translated length to be 10 plus 2W. Since the length has 2 terms, so 10 plus 2W is 2 terms representing one item. We always put those 2 terms in the parenthesis. Whenever we have multiple terms representing one thing, when we substitute, we always put them in the parenthesis. So basically, in the future, in module 9, we will actually use our distributive property to bring out the 2 terms. Plus 2 times, okay? W, the variable W representing width. So one term representing one thing, we do not need a variable for. So this is my answer. Okay? So in this lecture video, we briefly introduced these translation words. Okay? We did some example, just learning how to pick up on the translation words. Okay? So basically, don't try to think about what these problems says. Just simply translate what it says. It's just tricky. Sometimes we have to use parentheses. The key to understand some of these word problems is simply by translating. okay, what it says, rather than thinking about what it's trying to say. Because we can think about what it's trying to say after we translate it and solve for the whole problem. Okay, believe me, once you figure out what the answer is, then if you think back on what the problem says, it kind of makes sense. But when you first read it and trying to, use your brain juice to try to figure out what it's trying to say, most of the time it just doesn't make any sense because it's not meant to make sense. Because algebra is basically everything backwards. Okay. All right, so that will conclude this last lecture video for Math 106. And I hope you enjoy watching all the lecture video series, and I do appreciate you spend time watching them for this class. All right, thank you so very much. That will conclude this lecture video.